We looked at this. I'm not going to make you guess it again, but we did that one earlier. But it leads up to the verses we're working on right now. Since they did not see fit to acknowledge God, God gave them up to a debased mind to do what ought not to be done. This is the key. They didn't see fit to acknowledge God. He wasn't a big part of their life. They just want to leave him out. They either deny he exists, they try to suppress the knowledge of him, or they just try to ignore him. None of it works. So when that happens, God gives them up to a mind that will not function well, and it starts thinking crazy things ultimately. And they start doing things that ought not to be done and thinking that it's okay. They rationalize it. And so they were what? Filled with all manner of unrighteousness, evil, covetousness, malice. They're full of envy, murder, strife, deceit, maliciousness. They are gossips, slanderers, haters of God, insolent, haughty, boastful, inventors of evil. This is for kids. Disobedient to parents. And then these four words to conclude it. Not wise, but foolish. Not trusting, faithless, heartless, and what? Ruthless. Yeah. Very good. Come on in. I missed you last time. You okay, Aubrey? Uh, yes. So, and he's saying they do all these things because they don't see fit to acknowledge him. He gives them up to a mind, and they start doing stuff like this and thinking it's okay. Unrighteousness, evil, covetousness, malice, envy, murder, strife, deceit, maliciousness, gossip, slanderers, haters of God, insolent, haughty, boastful, inventors of evil, disobedient to parents, foolish, faithless, heartless, ruthless. And a lot of the stuff on that list, we think, oh, that's really bad stuff. And then other things, some of you may think, this is not really so big, is it? God says, yes, it is. It's all in the same list. It's all sin. It all leads to bad outcomes. And we will start to rationalize as soon as we leave him out. We'll start to rationalize. Go ahead, Jackson. We'll start to rationalize and think that this is okay. I'm different. My circumstances are different. Everybody would know this is okay for me. And we start saying sinful things are not sinful after all. And God says that's the cause you got a debased mind, or at least you're trying to leave me out for the moment. I guess all of us, to an extent, even as Christians, we're capable of trying to ignore God for a little while. We just don't want him to look. We don't want to. He's always there, and he knows exactly what we're thinking and doing, but we'll try to kind of ignore him, and it's always has a bad outcome. So there's one more verse here in this chapter. We're going to do it today. Though they know God's something something. Now, this means God's commands, but he's using two words to describe it here. You might be able to guess this. It means it's one of God's characteristics. He is what? Righteous. And this is another word for a command that you don't hear very often. Some what? Decree. That's right. I started to say it's like a king saying this is what's going to be. God's given a righteous decree. It's not just a command. It's a truth. It's a statement of what's going to be based on his justice. It's a righteous decree. That those who this is a word that means more than just do. It means do over and over and over. We sometimes use it in sports when they say we're getting ready for a game. Practice. Those who practice. Practice means you don't. All of us sin. We know that. It'd be foolish to say we never sin. But if I tell a lie now and then and I realize it, I say, Lord, please forgive me. I did it again. I shouldn't have told that lie. Please forgive me. And then we go to the person we lied to and say, please forgive me. I shouldn't have told that lie. That's one thing. We Christians will do that. But when we start developing a lifestyle of lying, where we just lie all the time, and we still call ourselves Christians, that gives us ground to say, wait a minute, am I really a Christian? Because that's practicing lying. That's just living a lifestyle of lying. Wouldn't have to be lying. It could be any other sin. I just picked on lying. But God's righteous decree is those who practice such things. Such things. He's talking about the stuff that we just saw that long list of. We've been through that now for a few days. People who live this way, they practice these things, deserve to what? Die. The death penalty. The wages of sin is death. God said that from the beginning. Adam and Eve, you're going to die now. And then that's what happens when you sin against me. Satan would like to say, oh, that's not fair. That's not fair. I mean, sin's not that big a deal. But if we could see it like God sees it, we'd realize, oh, sin is a hideous deal. And we'd recognize he's right. It deserves the death penalty. The wages of sin is death. Those who practice such things deserve to die. But they not only do them, but they give something to those who practice them. Those who are living this way, they'll say, oh, this is fine. This is good. They're giving their, what? It means we're saying, I think this is wonderful. I think what you're doing is just fine. What do you call that? Well, approval. They give approval to those who practice them. Though they know God's righteous decree that those who practice these things deserve to die, they not only do them, but they give approval to those who practice. And we're living in a culture like we are. Just this morning, I would encourage you to listen to this. Al Mohler, you've heard me talk about him before, probably. He's president of Southern Baptist Seminary in Louisville, Kentucky. But he has a program every day, a podcast program called The Briefing. And you can go to his website and listen to it or read it once they always transcribe it at some point so you can read it. But today he was talking about teachers in public schools in America making the decision, and we're talking about little bitty kids, 4-year-olds, kids that are just now starting preschool or preschool. What a 4-year-old goes into. So I guess 5-year-olds are in kindergarten. I guess they're in preschool. But anyway, and they said these teachers are deciding that the parents, if the 4-year-old's a little boy and he wants to be a little girl, that they're going to encourage him to be a little girl and even dress him like a little girl, and the parents don't even have to know about it. They're giving approval to doing things that God says is not truth. It's not true. If it's a little boy, it's not true that he can make himself a little girl. Little boys are little boys. They may have to learn how to be little boys. They may have to figure out what's going on. If they feel like they want to be a girl, they may have to figure out what's going on. Why am I thinking like this? They have to figure that out. They can be confused. And that's true for all ages. But God made us male and female. And we don't get to say, I don't like the way God made me. Same thing with sexual desires. They can be perverted. And now we're living in a culture that says, oh, this is good. This is good. This is good. They're giving approval to people who practice these things. We have to decide, are we Christians or not? And if we're Christians, we better be realizing this is God's word. And so we're standing on God's word and we're agreeing with God, not the world out there. A kid your age will be so immersed sometimes in celebrity culture, YouTube videos, movie stars who don't know anything about. They like to make pronouncements about what's right and what's wrong, but they're just actors. They're just singers. They don't know what they're talking about when it comes to ethics and morals. They don't know God's word, but they're making all these acting like they're great moral people. And a lot of kids your age are eating it up. You know them probably. I mean, you may be tempted. I don't know. But watch out, because it leads to a really bad outcome. Okay, that concludes Romans chapter 1. Do you have any thoughts or comments or questions? We're going to come back to this here. We're not through with it, but for now, we're through this. Okay? I mean, we'll review it like we always do. Anything you want me to pray about? All right, let's pray. Father, thank you so much for this day. Lord, thank you that you are the same yesterday, today, forever. You are God and you change not. And Lord, you've announced from the beginning that there is a right and there is a wrong. There is truth and there are lies. There is error. There is falsehood. Lord, you're a God of truth. And you're a God of righteousness and holiness. And Lord, you have called us to be your kids, all of us who trusted Jesus. Father, there may be kids in here who've said they've trusted Jesus, but they really haven't. There may be people in this building. There may be adults who said they've trusted Jesus, but really haven't. You know our hearts. But Lord, I pray that those of us who truly trusted Jesus, that we're really your kids, that we will keep our focus on you, that we will listen to you, that we will trust your word, that we won't be deceived by the celebrities and the people who are very clever and maybe funny and maybe great entertainers and maybe great singers and maybe even politicians or judges, maybe teachers, but they're ignoring you. They're leaving you out of their lives. They're leaving your word out of their lives, and they're trying to make pronouncements about what's right and what's wrong and what's good and what's evil. And Lord, they're confused, and we know they're confused, and you know they're confused. Help us not to be deceived by these people, but help us instead to be firmly anchored to your word and your truth and to stand in your truth. And Lord, thank you that you've warned us here today that even though they know that people who practice such things, they know your righteous decree, that people who practice such things are worthy of death, the death penalty for sin, Lord, is just very clear. You've made it very obvious in your word. They not only do them, but they give approval to those who practice them. We see it all around us. So we just pray again, help us not to be deceived. Help us to stand firm. And Lord, today, as we finish up our study of prophecy, to look at this incredible prophecy of Daniel that you gave through Daniel. Thank you so much for giving it to us. I pray to help these kids to absorb it and to understand it so that they can share it with others as you give them opportunity. We want to be more and more like Jesus. We want to be very useful in your hands. In a day when when the battle is raging hot, we want to stay in the battle and be effective spiritual warriors. So teach us how to do that, please. We pray in Jesus' name. Okay, math guys, this is Friday morning and you're not here. But if you remember, if you were here on Thursday, you know that I was having some pretty serious problems with my computer and this did not get recorded at all. And since you have a test coming up on Tuesday, I wanted to at least let you see me work the problems that are on that test review sheet you should have. So once again, I remind you almost every time we take a test, what you need to do is try to work those problems on your own. Make sure you know what you're doing. Don't just put down a bunch of junk. And then, if you have any question at all, you might need to watch this video, stop when I put a problem up, make sure you can do it. And then, if you can't figure out how to do it, or even if you think you have done it correctly, check yourself by watching the rest of it. Watch me do the problem. I'm not going to take a lot of time here. I'm going to work through it pretty quickly, so you'll have to use pause and restart. But that's always true of these videos. We only have 2 hours a week to get ready for tests that come pretty frequently, don't we? So anyway, here we go. This is where we left off. You had the earlier Tuesday video already uploaded. So here's the Thursday material we covered beginning at slide number 11, which is where we left off on Tuesday. This one says write each of these numbers as a decimal. So you got 2 2/5. The 2 part doesn't change. That's a whole number. This is what you're concerned about, the 2/5. How do you write 2/5 as a decimal? Well, that means 2 divided by 5. So you divide 5 into 2, put your decimal there, and then put it, when you divide, put it straight above the decimal in the dividend here. And then just divide like you always have. Won't go into 2, but it'll go into 24 times. 4 times 5 is 20, and that's the end of that. So there it is in decimal form. You don't leave the 2 off, though. It's 2.4. 2's still there, the whole number 2. Now let's look at the next one, 1/8. Of course, that means 1 divided by 8. So it's 8 divided into 1. Put your decimal there. Put you some zeros out there. You don't know how many you need at first. Just put a bunch of them. You can put as many as you want. Doesn't matter. Put your decimal straight above the decimal in the dividend. Straight up. 8 won't go into 1. 8 goes to 10 one time. 1 times 8 is 8. Subtract. Bring down. Just like you always do division. 8 goes into 20 2 times. 2 times 8 is 16. Subtract. Bring down. 8 goes into 45 times. 5 times 8 is 40. And that ends it. No remainder there. So there it is. That's all there is to it. 0.125 or 125 thousandths. Remember, this is the tenths. This is the hundredths. This is thousands. 125 thousandths. Okay. So if you have problems like these, and you probably will on the test, don't miss them. Round each number to the nearest thousands. You know what that means? That means the 4, 5 are repeated over and over and over. This means the same as this. 4, 5, 4, 5, 4, 5. Whatever that line is over, those digits repeat. Usually it's only over one digit. If it was over the 5, it would be 0.4, 5, 5, 5, 5, 5, 5. But it's over the 4, 5, so it's 4, 5, 4, 5, 4, 5, 4, 5. You can just keep going. But we don't need to go too far because we're looking for the nearest thousandths. This is tenths, this is hundredths, this is thousands. That's what we're trying to decide. Is it a 4 or is it a 5? You're either going to leave it a 4 or you're going to round it up to a 5. And this tells you round it up to a 5. It's 0.45 5. If this had been a 4, 3, 2, 1, or 0, you'd have left it a 4. If it's a 5, 6, 7, 8, or 9, you round it up. Always follow that same pattern, 0.55. The next problem has a whole bunch of things that repeat, but we're only interested in the thousands. I mean, I could write this out 3.142857, 142,857, 142,857, but there's no point because we're rounding to this digit, this decimal right here. That's tenths, that's hundredths, that's thousandths. That's what we're rounding to, thousands. So I look at this one and it tells me to, again, round it up. So it's 3.143. Round that up to a 3. That's the end of that problem. No sweat. Divide 1.9 by 12. Now don't put these down wrong. 1.9 divided by 12 means 12 divided into 1.9. The 12 is the divisor. You're dividing by 12. 12 is the divisor. There's no decimal here in the 12. There is one here, but you're used to that. You just raise it up there. 0, 1, 12, 7. Let's put some zeros out here so we can keep going. Bring down a 0. 12 goes into 70. You know your multiplication tables? 5 times 12 is 60. 6 times 12 is 72. 6 is too big, so 5 works. 5 times 12 is 60. Subtract, bring down. 12 goes into 100. If you don't remember these, you really should know these by now. You know, I've urged you all year long, memorize your multiplication tables. You can memorize phone numbers. If you can memorize stuff from the internet, if you can memorize song lyrics, you can memorize your multiplication tables. It is not as fun, I understand, but you need to do it. So, how many times does 12 go into 100? Well, 9 times 12 would be a little too big. It's 108. So 8 times 12 turns out to be 96. Subtract, bring down. 12 goes into 40. That's easier. 3 times 12 is 36. Subtract, and now we see a pattern. It's going to keep repeating, isn't it? You're going to keep getting 4s here. 3 times 12 is 36, and it just keeps going. Those go on and on and on forever. So this said, divide 1.9 by 12 and write the quotient with a bar over the rep of 10. What's the rep of 10? It's the 3. Not the 8-3, not the 5-8-3, not the 1-5-8-3, just the 3. That's the only part that repeats. So you'd write it like this, 1-5-8-3, and then a bar over the 3 only, which means it just keeps repeating. And then it says rounded to 3 decimal places. Well, here's the 3rd decimal place. That's thousands. And that's a 3. So this time I don't round it up to a 9. I leave it an 8. 1, 5, 8. Yeah. If that had been a 4, if it had been a 5 or a 6 or a 7, you would have rounded that up to a 9. You know that by now. Okay. Write 8% as a decimal. 8%. There are 2 ways you can look at this problem. Percent, you remember, means divided by 100. This is the same as 8 over 100. Well, that's 8 hundredths, and you can write 8 hundredths as a fraction, or you can write 8 hundredths as a decimal, like that. That's the hundredths place. Or you can simply remember that to change a percent to a decimal, you move that decimal place 2 places to the left, which will give you 0.08. You got to put a 0 in here. So you'll have another place to move it over to the left. So it's 0.08 when you change it to a decimal. Then it says find 8% of $8.90 by multiplying $8.90 by the answer to what we just got, 0.08. Most all the time in math, when you're multiplying by a percent, you're taking a percent of something. First, change the percent to a decimal. That's what we did right here. Change it to a decimal. And then multiply. Of means multiply. Percent of means decimal times the number. So it's 8.90 multiplied by 0.08. And remember, when you're multiplying, it doesn't matter whether these decimals line up or not. When you're adding or subtracting, you got to line them up. But when you're multiplying, it doesn't matter where they are. You ignore them at first. At the end, you'll count the decimal places. 8 times 0, 8 times 9 is 72. Carry the 7. 8 times 8 is 64, and 7 makes 71. And then you got four decimal places here. 1, 2, 3, 4. So the decimals, you got to go right here. 0.07120. There's the answer. It says rounded to the nearest cent. Well, that would be the nearest cent, and 2 tells me I'm going to leave it there, so it's 0.71 cents. It's $0.71, really, 71 cents. Okay. Now, I would urge you, try to think logically here. 8% is really close to 10%. And 10% of this, a tenth of that, we just move that decimal one place to the left, which would be 89 cents. But that's more. This is only 8%. But 89 cents is close enough to 71 cents. If you got $7.10, well, that doesn't make any sense. Think about whether your answer makes sense or not. Yeah, it makes sense. Evaluate A, written beside the parenthesis, means multiply. A times B plus C. If A is 2, B is 3, and C is 4. This should remind you of something. This reminds you of the distributive property. The distributive property looks like this, but you don't have to use the distributive property here. You just substitute a 2 where the A is, that's a 2. A 3 where the B is, that's a 3, plus a 4 where the C is. And do what's in parentheses first. 3 plus 4 is 7, so that's 2 times 7. And of course, that's 14. Just as practice with the distributive property, though, A times B and A times C means AB plus AC. This is the same as AB plus AC. That's the distributive property. AB would be 2 times 3, that's 6. AC would be 2 times 4, that's 8. And 8 and 6 is 14. Same answer. This is probably easier for most of you, but it's nice for you to be familiar with the distributive property. You're going to see it a lot. Rectangle was 24 inches long and 18 inches wide. What was the ratio of its length to width? In class, if you remember, I stopped at that period and didn't read this last thing. I said, whoa, a rectangle, let's draw it. And we drew it. But in this case, you don't really need to draw it, do you? They're asking about the ratio. They're not asking for area. They're not asking for perimeter. There's no point in drawing it. Length to width. That means length to width or length over width, either way you want to write it. Most of the time in math classes, we'll write it as a fraction. But the length is 24 and the width is 18. So it's 24 to 18 or 24 over 18, which you can reduce and probably should reduce. 6 goes into both of those. 4/3, 4 to 3. 4 to 3 is the ratio, 4 to 3. But if you put 24 to 18 on the test, and this was the problem, I wouldn't count that wrong because it's correct. It's just not reduced. If they ask you to simplify or reduce it, then you need to go ahead and reduce the fraction. For full credit. I give you partial credit if you get it partially right. Lakeisha's test scores were 90, 95, 90, 85, 80, 85, 90, 80, 95, and 100. What was her mean average test score, and what was her median score? You really should remember that these two words are synonyms in math. Mean and average mean the same thing. So we're looking for the mean, the average, and we're looking for the median. Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores here. And you probably are ahead of me. You know you got to add them up first to get the total. So let's add 90 and 95. And listen, guys, when you do this, be careful. Double check yourself. Make sure you're not copying something down twice or leaving something out. 95 and 100. And I'm going to count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like I've got them all in there, but I'm going to double check, make sure I didn't write one down twice and leave another one out. 90, 95, 90, 85, 80, 85, 90, 80, 95, and 100. Check yourself over and over and over. A lot of mistakes on tests are just careless mistakes because you didn't check yourself. Now let's add. There's 5, 10, 15, 20, and they made that kind of easy. Carry the 2. I've got 1, 2, 3, 4, 5 nines, which is 45, and 2 makes 47. And I've got 1, 2, 3, 4 eights, that's 32. So that looks like 979. Is that right? Unless I made a careless mistake, so I better double check myself. 1, 2, 3, 4 eights, that's 32. Well, oh, I didn't get that one in there, did I? 1, 2, 3, 4, 5 nines is 45, and 2 makes 47, so that's 79. But I got to carry it. I'm going to put that 7 here and carry that 7 over here and add it there and get 890. Now, guys, think with me here. Well, let's do the mean first. The next step is to divide by 10, which is easily 890 divided by 10 is 89. You know that. Now think about it. Ask yourself, does this kind of make sense? Would it make sense that 89 might be the average of all these numbers? The reason you ask that question, think about it. If I had left out a 79, if I'd left out 790 and divided by 10, I'd got a 79. And then, does that make sense? Does it? Does 79 make sense? Doesn't make any sense at all. The lowest grade on here is an 80. There isn't a grade lower than an 80. The average can't be 79. You see what I'm saying? So you realize, whoa, that doesn't make any sense. I made a careless mistake. And you go back and you find it. And you find that, well, I didn't carry that 7 correctly. So 89 fits in there okay. That sounds like a reasonable mean or average. Now, how do you find the median? Well, the best way to remember this is picture a highway, and you got, say, 2 lanes going this way, and then a grassy strip here, and 2 lanes going the other way. So, split the dual highway. This median part here, this part in the middle where the grass is, or the barrier, is called the median. The median. The median. It means the middle. MED for middle. Okay, that'll help you remember. It's the one that comes in the middle of all the others. So the next question is, how do you find the one that comes in the middle? Now do it the way I'm telling you to. Don't get careless here. You can try to get in a hurry and make a real careless mistake real easily. So what you're going to do is put these same numbers down again, but start with the lowest ones and work your way up. There's an 80 that I'm going to put down here. I'd mark it off to make sure I don't pick it again. There's another 80 right here. Are there any more 80s? No, but there's an 85 right here and another 85 right here. Is that all 85s? Yep. There's a 90 right here and another 90 right here and another 90 right here. That's all the 90s. And there are a couple of 95s. Another 95. And 100. 100. Now, I'm going to count them, see if there's still 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Check yourself. You don't want to leave something out. You don't want to put something in twice. Now, to find the one in the middle, the easiest way is to start marking them off from the outside. Mark off the lowest one and the highest one, and the next lowest to the next highest, and the next lowest to the next highest, and just keep going until you either reach 1 or 2 in the middle. If you reach one number, if there are an odd number of numbers here, and so you wind up with one number, that's the median, you're done. If there are 2, you have to have the average of those 2, the number right between those 2. Well, these 2 happen to be the same number. So it's just like there was 1, so the median is 90. 90, when the average of 90 and 90 is 90, of course. That's the median. There you go. Don't miss that. If you want to draw a diagram here, you may, but I suggest at this point, most of you can say 5/6. That's this. Of means times, raised dot, 300. Finish the marathon. 5/6 of 300 means 5/6 times 300. How many did not, read this carefully, did not finish the marathon? 5/6 finished it. That means 1/6 did not. So 1/6 of 300, 6 goes to 350 times, that's 50. 50 times 1 is 50. 50 did not. Another way to do that would be to calculate how many did finish. 6 goes to 350 50 times. 5 times 50 is 250. And if 300 were in the race and 250 finished, then obviously 50 did not. Just subtract. Either way works. All right, look at this. What was the ratio of runners who finished the marathon to runners who did not finish the marathon? Again, there are two ways to look at this, but the easiest way is to say, well, 5-6 finished, 1-6 did not, so the ratio is 5-1. 5-1. You can write it as 5/1 or 5:1, either way. 5-1. But you could say, well, there were 250 finished and 50 who did not. That's 250 to 50. But when you reduce that down, it's 5-1. Same answer. Here's an equation to solve. I particularly don't like these equations at the level of math you are right now. When you get to algebra, these will make a lot more sense. But what you're going to have to do with an equation like this right now is just kind of use your common sense and think, okay, I got to subtract something from 1. And when I do, I'll get 0.1. This is what I'm trying to find, this z. I've got to subtract some number from 1 to get this. So if your brain says, well, I better add this to 0.1, well, if you add 1 to 0.1, I get 1.1. And 1 minus 1.1 is not 0.1, it's negative 0.1. That's too big. That's bigger than 1. See what I'm saying? So the answer is to add these two together. So well, maybe I need to subtract them. So I got 1 and subtract 0.1. Notice I put a 0.0 after this so that it'll have the same number of decimal places as this one. Makes it a lot easier to work with. When I subtract, I borrow that 1 and I get 0.9. And then I ask myself, well, is that true? Is 1 minus 0.9, if that's 0.9, if I subtract it, do I get 0.1? The answer is yes, I do. So that's the way you do this problem. You're going to subtract this from the 1, and you'll get 0.9. But test yourself. When you get your answer, plug it in where the z is and see what you get when you subtract it from 1. If you don't get this, you made a mistake. Perimeter of this rectangle is 48. What's its width? Now, some of you may think width, that's this distance. No, that's the length. Width is the shorter distance. So in this case, this is the width, this is the length in a rectangle. Now they're telling you that this side down here, the length is 16. Well, if this side's 16, then this side's got to be 16 also, right? So there's 32 inches right there. 16 and 16 is 32. That means I've got to have how many more? Well, 48 minus 32 is 16 more inches. And it's got to be equally divided for each side. So I've got 8 over here and 8 over here. So its width is 8. Now again, I would suggest you check it. When you add 8 plus 16, you get 24. Another 8 is 32, and another 8 is 48. It adds up to 48. Check yourself. Don't make careless mistakes, or try to make as few as possible anyway. Here's an election tally. The winner of the election received how many more votes than the runner-up? Well, let's go ahead and just put down how many votes each got. These are 5 marks for 5, 10, 15, 16, 5, 10, 14, 5, 10, 15, 20, 22, 5, 10, 15, 18, right? Okay, there's Judy got 16, Carlos got 14, Yolanda got 22, and Con got 18. The winner, that's Yolanda, got 22 votes, received how many more votes than the runner-up? Well, the runner-up is Con, 18 votes. So you're just going to subtract these, and the answer is 4, 22 minus 18. What fraction of the votes did Carlos receive? Carlos got 14. But how many votes were cast? Well, you're going to have to add them up, aren't you, to find the total number? So 8 and 2 is 10, and there's 10 more. That's 20. Carry the 2. 2, 3, 4, 5, 6, 7. 70 votes. You might want to double check that. 16 and 14 add up to 30. 22 and 18 add up to 40. And 30 and 40 add up to 70. Yeah. Double check yourself. Now, what fraction of the votes did Carlos receive? Well, he got 14 out of a total of 70. So the answer is 14 out of 70. That's it. If you were taking a multiple choice test, that would probably reduce. 7 goes into both of those, 2 and 10, and 2 goes into both of those, 1 and 5. So 1/5 is the best answer. But if they don't ask you to round it or reduce it, I'm going to say, not round, reduce. If they don't ask you to reduce it, I would say that's the correct answer. I wouldn't count it wrong. This is maybe a better answer, but I wouldn't count that wrong. All right. 4/7 of those who rode the giant gyro at the fair were euphoric. All the rest were vertiginous. What fraction were vertiginous? Well, 4/7 were euphoric. 4/7 were euphoric. I'll call it E for short. All the rest, well, that would be 3/7, right? 3/7 were vertiginous. So that's the answer A, 3/7. It's the rest of them. 4/7. There's 7/7 in all, so there are 3 more 7s there. What was the ratio of euphoric to vertiginous? Well, there's 4 euphoric for every 3 vertiginous. So it's 4-3, or 4/3. You can't calculate how many were euphoric or how many were vertiginous this time because they don't tell you how many there were in all. So you don't have any numbers to work with. You just have to work with the fractions. 4-3. Here's a simple proportion to solve, and you can cross multiply if you remember the rules for solving proportions. Cross multiply. However, and it works, you don't have to do what I'm going to say next, but it'll be easier if you have a fraction that will reduce, and it's obvious that it'll reduce. You ought to reduce it. You'll have smaller numbers to work with, and that's the same as 1/4. So I could write this fraction as 3/w equals 1/4, and it's exactly the same thing. I could write that fraction as 1/4. 25 goes to 25 one time into 100 4 times. Now you can still cross multiply, and you get 3 times 4, which is 12, and w times 1, which is w, and that's the answer. W is 12. If you forgot, that's not a problem. You got 3 times 100 is 300. 25 times w is 25w. Now what do you have to do? To undo the multiplication, you have to divide. That gives you a w over here. What's 300 divided by 25? 12. You might have to go over the side and do that. If you forgot, you can divide 300 by 25. All right. Here's a division problem, only this divisor is different from the ones we've done so far. This is a decimal divisor. It's not a whole number. So what you do, you divide is 0.12. The dividend is 0.096. What you have to do is make this divisor a whole number. By the way, if you want to, you could say, I'm going to write this down kind of like a decimal fraction here. Decimal on top, decimal on bottom. I could multiply both top and bottom by 100, and I'll get 9.6 on the top and 12 on the bottom. That's kind of what we're doing here. We're multiplying by 100. But all you have to remember is move the decimal in the divisor, all the way to the right. Use a different color. Move it all the way to the right. That's 2 places. Goes right there. Which means this has to move 2 places also. You got to move the decimal and the dividend the same number of places. And then you put it up here. So you're doing away with those decimals. You're moving it 2 places to the right here and 2 places to the right here. It's the same as multiplying both of them by 100. And now you divide just like you divided by 4, just like you divided by whole numbers 4. So to make it easier to see, this was a 12 now. And over here, I've got 9.6 now. You see that? This is a 12. I moved it 2 places to the right. This is a 9.6 when I move it 2 places to the right. So now I just follow the old-fashioned rules for dividing. Put the decimal up here. It won't go into 9, but it goes into 96 8 times. And no remainder. That's nice. 0.8. Okay, one more, and you'll have all these done. This is division problem, two mixed numbers. You remember your first step when you're dividing mixed numbers? First, change them both into improper fractions. Don't try to do two steps at once. Just change them both into improper fractions. 5 times 6 is 30, and 3 makes 33 over 5. Divided by, don't flip it yet. Just leave that division symbol there. 10 times 1 is 10, and 1 makes 11. 11 tenths. Double check yourself. 33 fifths, 11, 10 and 1 is 11 tenths. Now, follow the rule for dividing fractions. This stays the same. Leave. Change this to multiplication and write down the reciprocal of this. Here's the rule. To divide by any number is always the same as multiplying by the reciprocal of that number. To divide by any number is the same as multiplying by the reciprocal. Most of you probably remember it as leave, change, flip. Leave, don't change the first one, change, division to multiplication, and flip the reciprocal. Now you can multiply. But you could multiply 33 times 10 and get 330, and 5 times 11 get 55. There's nothing wrong with that. But it's easier if you cancel first. And 11 goes to 11 one time and 33 three times. And 5 goes to 5 one time and 10 two times. And 2 times 3 is 6 over 1, which is just 6. That's the answer. Okay, I hope that helps. I hope you do well on the test. If you need to, watch it more than once. And if you can't understand something when you come here before you take this, ask me. I'll be glad to answer a question for you before the test. God bless you. Have a good weekend. And 2/5 is the same as 0.4.